right here, formula 12 on your formula sheets has the antiderivative. The antiderivative tangent of u is natural log secant u. So I would like us just to look at this real quick because there's a good little lesson in this problem. Nothing complicated, but there's a good lesson. Right? If we were going to do this without the formula, right? Without that, then everything we've done today, this doesn't fall into that category, right? This is not a sine, this is not a cosine, this is not secants and tangent. Well, there's tangents here, but we would need a secant with this in order for us to do something like this. So whenever you're doing a trig integral, right, here's the main point. If you're doing a trig integral and you're not sure what to do, rewrite everything in terms of sine and cosine. Okay? So I'm going to rewrite this. Tangent, we know by definition, is what? Sine x over cosine x? And if I look at that long enough, I realize I can do a basic u sub. What would the basic u sub be? Do you see something in its derivative? Cosine x, its derivative is negative sine x, which is on top, right? You're off by a sine. You can't do it the other way around, though. You can't let u be sine x because the derivative would be in the denominator. So you'd have to let u be cosine x. The derivative of that, negative sine x dx. We don't have a negative, so I multiply both sides by negative 1. Let's see, Jacob?
Yes, sir.
What does this new integral become?
The integral of sine x over u times du over negative sine x. Negative comes out, and the sine cancels.
So you're left with
Over u.
1 over u du with the negative out there, right? Like that? Everyone see that? I'll just come over here and I'll just rewrite this like this. This is 1 over cosine x times sine x dx. So you replace that with negative du. This becomes 1 over u. The negative comes out. What's the antiderivative of that, David? Where's David?
The natural log.
Natural log, right? So negative, forgot the negative. Negative natural log of what? Just, hold on.
Cosine.
Just cosine. Natural log, absolute value, right, of cosine of x plus c, right? That's what we get. Okay. Is that what's on the formula sheet?
No.
No. So did we make a mistake?
No.
No? So they have that it's the answer should be natural log secant, right? Natural log secant x plus c. That's what they have. So what do you do? 1 over cosine is that, but how this is we don't have 1 over cosine. We have cosines. That negative 1 can come up as a power. Remember that property of logs, that if you have a power, you can bring it out? Well, if you have a number in front, you can take it up as a power as well. So what I can do is I can rewrite this as natural log absolute value of cosine x to the negative 1 plus c. And you have to be real careful here. Cosine x to the negative 1 does not mean the inverse cosine in this particular case. It means 1 over cosine, which is secant. So it's the same answer. All right. Y'all doing okay here? Yeah? Hanging in? Okay. So you're going to need to do your homework for that, right? I will tell you here in a second. Your homework, I'm not done for the day, but just so we can kind of see where we are here. Your homework for the 6.2 is 1 through 61. It's a lot of problems, okay? But we have not finished this section. We are only halfway through this section. So I'll tell you before we end class or at the end of class, I'll tell you which problems to do. I want us to look at the next. I want to start dabbling into what we're going to do next time. I want to do a problem right now. Okay. So let's take a look at a new integral. So this is the beginning of this thing called trigonometric substitution. Historically, this just causes problems for students. I don't know why. It can be complicated, all right? But you'll do fine. There you go. Maybe by parts. I mean, if you did by parts, what are you going to choose, right? How about a basic u sub? Do you see something in its derivative? I should be clear here. That 3 is a cube on the x. That 3 is a cube on the x, not a cube root, okay? So maybe a basic u sub, but what are you going to let u be? 60 minus x squared. What's the derivative of that? Minus 2x. So you have an x cubed out here, though. You could maybe peel an x off. Okay. So maybe there's some things you can do here, right? Maybe there's some things you can do. I'm going to show you something new, all right? This thing called trigonometric substitution. And the thing about trig sub that I guess kind of like startles people at the beginning when they first see it is that what we're going to do is we're going to make a substitution. But we're going to make something that's nice more complicated. Usually what we do is we try and make a substitution like, hey, we're going to replace all our cosines, right? Everywhere we see a cosine, we replace it with a u, and then this new expression is going to be nicer, right? Here, we're not going to do that. We're going to replace x with something more complicated, and things are going to be great, all right? So right now I don't want you to think about why I'm doing this yet, okay? I'm just going to do it, and then you just tell me whether or not you agree with this, all right? I'm going to do something weird. Right now I'm going to make a substitution. I'm going to let x be equal to 4 sine theta. What? Right? I'm making a decision right now that everywhere I see an x, I'm going to replace it with 4 sine theta. That doesn't look natural, right? That looks really weird. Okay? And next class I'll get into why we're doing it, and I just want to show you right now that this is actually going to work. All right? So if I let x be 4 sine theta, do you agree with this next line? The derivative of that would be 4 cosine theta d theta. Do you agree with that? If I take derivative of x, right? 4 comes down, derivative of sine is cosine theta d theta. Yeah? All agree with that? Okay. Now this part's the really cool part. What does the square root of 16 minus x squared become? So if I tell you that x is 4 sine theta, I'd like for you to look at this complicated square root expression. I'd like for us to investigate what would happen to it if I replace that x with 4 sine theta. It would become 16 minus, okay, imagine squaring this. Let's go ahead and write what x squared is right here. What's x squared? If I square both sides, what do you get? 4 sine squared theta, right? Not 4, sorry, 16. 16, right? So you square the 4, you get 16. You square the sine, you get sine squared, right? So now this becomes 16. Take away that, right? Do y'all agree? Yeah. Do you agree that they both have a 16? So I can factor 16 out. They both have a 16. I can factor 16 out, right? What is 1 minus sine squared theta? Cosine squared theta. Isn't it? Yes. So this is just the square root of 16 times cosine squared theta. See, I no longer have subtraction. I have two factors, don't I? So when you have two factors and you take the square root, can't you now just take the square root of each one? Square root of 16 is 4. Square root of cosine squared is cosine. Huh. Isn't that nice? Isn't it nice that this ugly thing really turns out to just be that nice thing if I make that substitution? Right? I haven't done the x cubed. I haven't asked you to think about x cubed yet. I've just asked you to say, hey, look, I'm going to replace all the x's with 4 sine theta, right? The derivative of that would just be 4 cosine theta d theta. Everyone agreed with that. And I said, hey, that square root thing turns out to be that, right? Now, I'm going to rewrite the whole integral now in terms of theta, right? So now I'm going to address that x cubed. I'm going to write the integral down first. Okay. X cubed, well, what's x for us? 4 sine theta, right? So I'm going to cube that. 4 sine theta, I need to cube that, right? Times this, square root of 16 minus x squared, becomes 4 cosine theta times dx. What's dx? 4 cosine theta d theta. 4 cosine theta d theta. I've rewritten everything. This becomes this, right? This became that. And this becomes this, right? Do y'all see what I've done? What type of integral is this? Trig, right? This is what we just spent time doing, right? Okay, so let me clean this up. When I cube this, it's 4 cubed, right? Yeah. And then times 4 again. So isn't that 4 to the 5th power? 4 to the 5th power? I can take that out of the integral completely. I'm going to do that. So we're at 4 to the 5th power, whatever that is. I'll get that on my calculator later. 4 to the 5th power. All right, how about sine theta? How many sines do I have? How many factors? Right, cubed, sine cubed. So sine cubed theta. How about cosines? Cosine squared. Yes? Cosine squared? Who has questions? Who has questions? Everyone understand where the 4 to the 5th came from? Everyone understand where sine cubed came from? Cosine squared. Now, we have a trig integral. We've got sines and cosines. The steps for this is to first look, is sine to an even or odd, or is sine odd? Yes, sine is odd. If sine is odd, what do? Kick a sine out to the backside, right? And that'll leave you with a sine squared. We'll rewrite that sine squared in terms of cosine. We'll make the substitution u as cosine, and then this should work. So do you see you have to be good at like what we did earlier today to do this stuff? All right. So let's go. Question? What? This is multiplication, right? So this is 4 cubed times sine theta cubed. That's what this means, right? Cubing each one. And then you had a 4 here and a 4 here. So you're doing 4 times 4 times 4 times 4 times 4. Right? Okay. Any others? Yes. Yes. First see if cosine is odd, which it's not, right? And then you go to the next step, which is sine is odd, and then that's when you peel off the sine, right? Yeah, had cosine been odd here, I would have popped a cosine out. I want to do it right here. No, I want to leave that there. How much time? 10 minutes. Okay, we got this. We got this. You ready? This is going to be 4 to the 5th integral. This is now sine squared theta, right? Cosine squared theta. Sine theta, right? Because I peeled off that sine theta. D theta. So there's me peeling off one of those factors of sine. And now I'm going to make this sine squared become a what? 1 minus cosine squared. Because this right here is going to be the derivative of cosine. So everything over here has to be in terms of cosine. I don't want to erase this. Actually, I'll erase that. But I'm going to keep that up there. So this now becomes 4 to the 5th integral. All right, sine squared becomes 1 minus cosine squared theta. And then I have cosine squared theta, sine theta, d theta. U is now going to be cosine. Anybody have a question right now? U is going to be cosine theta. Du then would be negative sine theta, d theta. So we do have a negative here, don't we? We have to deal with the negative? Because we don't have a negative there. So I'm going to put negative du is sine theta, d theta. Okay, I think I'm ready to rewrite the integral, but I'm going to ask somebody here. Let's see here. Madison? How you doing over there? Good? You following? Okay. Are you ready? Are you ready to rewrite this in terms of u? Feel like you could give me what this is? Okay, go for it. What do you got?
1 minus u squared.
Okay, so 1 minus u squared. U squared times du. This right here, right? Is you're writing that part? Be careful. It's not du. It's negative du, right? So is it right if I pull that all the way out? Yeah? Okay. So I'm going to put, everyone pay attention here. I've got a negative in front of all this now, right? Because it's a negative du. All right. Do we feel good about this? Yeah? We could just, what? Distribute and then do each one, right? Okay, let's keep going. Bless you, bless you. All right, negative 4 to the 5th power integral. I'm going to distribute that through. It's going to be u squared minus u to the 4th, right? Du. I think we can get this antiderivative, yes? Okay, so this is going to be negative 4 to the 5th, parenthesis, 1/3 something cubed, right? What's my substitution? Cosine theta. Cosine cubed theta. And then minus cosine, 1/5, right? 1/5 cosine to the 5th theta plus c. Yeah? Did I go too fast, or is that, we've done enough of these, I think, hopefully, right? 1/3 u cubed, 1/5 u to the 5th, replace u's with cosines. Box it up. Our answer is in terms of what variable? Theta. What is our original problem in terms of? X. You're not done. We need to somehow get from theta back to x now, right? How in the world are we going to go from theta back to x? With the one connection we have between theta and x that I established from the beginning of the problem. I said x was 4 sine theta, right? Guess what I'm going to do now? What were our preliminary topics for today? Reference triangle. Reference triangle. Okay. Now, in this problem, I might be able to figure out what cosine of theta is easily. All right? I might be able to look back and say, oh, somewhere in here I know what cosine theta is in terms of x. But the best way to proceed, I think, that'll get you through every problem that you ever run into like this, is to go back to this, where you made the substitution, and draw your triangle. So this is x over 4 sine theta, right? Okay. From that, I'm going to draw my reference triangle. This is theta. Sine is opposite over hypotenuse. Is that the problem I did earlier or no? It's not, right? When I started class, the prelim, what did I have? X was it 3? 3. Oh, I should have used 4. It would have been nice, huh? But we can solve for this side, right? I'm not going to go through the work. Call it a and then do your Pythagorean. This should just be square root of 16 minus x squared. That's what it'll be if you go solve it. Do you think it's a coincidence that that's what this root is? No, it's actually, I mean, that's like where it all came from. I mean, so it's not, should be no surprise that one of the sides of the triangle is that expression. Okay, once I have this, right? Once I have this, can't you tell me what sine theta is, cosine theta, tangent theta, secant theta, cotangent theta? All 6 trig functions you could tell me, right? You could convert thetas to x's. So now I'm just going to write, what from this, what's cosine theta? It's the square root of 16 minus x squared over 4. That's what it is. So back over here, I'm going to replace this cosine cubed theta. I'm going to rewrite that as the square root of 16 minus x squared over 4. That's cosine theta, right? Cubed. And then minus 1/5, and then cosine theta, 16 minus x squared, all over 4 to the 5th, plus c. That's it. That's it. We can clean up more if we want. I mean, we could actually like cube the top and bottom. Most importantly, if you cube the bottom, it's 4 cubed, and then when you distribute this 4 power through, things kind of cancel out. I'm just going to leave it like this for now. There it is. On a test, you could leave it like that as well. I'd be happy with that. But you have to get it back to x. You can't leave your answer in terms of theta. It has to go back to x. So this is your first example of trigonometric substitution. Yes? That's probably not the only way you could have done this. Let me see, what would have happened if we would have just let u be equal to 16 minus x squared? Du is negative 2x dx. I think this would work if we rewrote this. If we rewrote that integral like this, x squared integral 16 minus x squared, move the x dx, like peel that x off to the back, we might be able to get it to work this way. Because then you could write that x squared is 16 minus u. So if we rewrite this integral, that becomes 16 minus u. The square root of this stuff would be the square root of u. And then x dx, that's times negative 2, or negative 1/2, sorry. Negative 1/2. I'm going very fast here through this, but this would turn into this, and that you could do without, you could do this. This would be easy. You just distribute through. So, but trust me, I can give you a problem where you cannot do this, okay? There are problems that can only be done with the trigonometric substitution. This was our first example, so I just wanted to show you. Yes?
So when you started out that last problem, you said let
X be 4 sine theta.
Are you going to give us that, or do we have to derive that?
You will have to derive that, but I will tell you what you're looking for, okay? Like that's what next class will be. It's like, I'll tell you what told me, okay? What told me was this right here. That right there looks like this. Square root of some constant squared minus x squared. When I see that, I'm going to do something in particular, okay? I'm going to tell you exactly. Next class, I'll tell you. Anytime we do that, it'll be a sine theta. That'll be the substitution. And if it was the other way around, if it was x squared minus a squared the other way around, I'm going to do something else. And if it's pluses in between them, I'm going to do something else. There's going to be 3 scenarios. So I'll give you that next time. Okay? Does anybody have, no one has the ebook open or textbook, do they? Okay. I want to tell you what problem to go up to. So give me a moment. Oh, I'm out of time. Everyone's going to have to wait. So are we going to do the same thing next time where I give you a quiz problem that's a homework problem? I think that's a great idea.
Yeah, I like that.
When you say next time.
Next class. I need to keep you all on this. You've got to do this stuff, okay? Because this stuff will leave you behind real fast if we don't stay on top of things. Let me see here. Almost there.
Never mind. Good luck.
Almost there, almost there. All right, so 6.2.
We're treating those as indefinite.
Wait, is this 6? No, this is 6.2. Yeah. So in theory, the first 35 problems can be attempted. Let's say first 34. Yeah. Yeah. Yes. Yeah, you're still ignoring the numbers. The definite integrals, you're ignoring those. You're just trying to find the antiderivatives of those. So I promise you next time a quiz out of problems 1 through 34. I'm going to just pick a problem, and that'll be your quiz, and I'll give you a few minutes to do it, all right? Questions? Good? Okay, y'all have a good day.